Looking at section 7.1, systems of linear equations in two variables. This is a little review back to some Algebra 1 stuff, but just to make sure that we have those skills, we're still going to cover it. So we're going to decide whether an ordered pair is a solution of a linear system, solve a linear system by substitution, solve a linear systems by addition, identifying systems that do not have exactly one ordered pair solution, and solving problems using systems of linear equations. So as I mentioned, a bunch of Algebra 1 review, but let's see what we got. A system of linear equation and their solution. It says all equations in the form ax plus by is equal to c are straight lines when graphed. Two such equations are called a system of linear equations or a linear system. A solution to a system of linear equations in two variables is an ordered pair that satisfies both equations in the system. A linear system that has at least one solution is called a consistent system. Something that's consistent, you expect to get an answer from it. So a consistent system has a single solution, an ordered pair answer. It says that a linear system with no solution is called an inconsistent system. You don't get an answer. It's not what you expected to get. So let's start with determining whether ordered pairs are solutions of a system. So they give us two equations. We have a 2x minus 3y equals negative 4. We have a 2x plus y is equal to 4. And they want you to determine if the ordered pair 1, 2 is a solution of the system. So ordered pair, x value and y value, plug them in and see if it works. So we would have 2 times our x value of 1 minus 3 times our y value of 2. We want to see is that equal to negative 4. So we'd have 2 take away 6. Is that equal to negative 4? Yes, it is. Plug into the other equation. 2 times 1 plus 2. Is that equal to 4? 2 plus 2 is equal to 4. Yes, that is. So that means our ordered pair, 1, 2, is a solution. You can easily write yes or no. Let's try another one. If I have the equation 2x minus 3y is equal to negative 4 and 2x plus y is equal to 4 are the same equations, but this time they want to know is 7, 6 a solution of the system. So again, I'm plugging in my x value and my y value. So 2 times 7 minus 3 times 6, is that equal to negative 4? So I want to know is 14 take away 18 equal to negative 4? Well, that works. What happens if I take a 2 times 7 and I add 6? Is that equal to 4? 2 times 7 is 14. 14 plus 6, is that equal to 4? No. So 7, 6 is not a solution. Nice, easy Algebra 1 stuff, right? All right, let's take a look at how we solve by substitution, or a recall of how we solve by substitution. So step number 1 says solve either of the equations for one variable in terms of the other. So it says if one of the equations is already in this form, you can skip this step. In other words, you are looking for an x equals or a y equals, and it doesn't matter which one it is. You want one variable solved for itself. Step number 2 says to substitute the expression found in step 1 into the other equation. This will result in an equation in one variable. So we solve the equation containing one variable, and then we back substitute the value found in step 3 into one of the original equations, simplify and find the value of the remaining variable. Your goal is to get your ordered pair answer. And then always check the proposed solution in both of the system's given equations. You want to make sure that it works. So let's try one. So if we were to have a 3x plus 2y is equal to 4 and a 2x plus y is equal to 1, they would want you to pick one equation and solve for one variable. So if you look at these equations, the second equation has a y that's almost all by itself. So they're going to have you in step 1 solve that equation for the easiest variable, which in this case is y. So if we solve to get y all by itself, we would end up subtracting that 2x over. And I don't care if you call it a 1 minus 2x or put it in slope-intercept form of a negative 2x with a positive 1, whichever works, just as long as your signs are correct. Then in step 2, we're going to substitute that expression. We're going to take that negative 2x plus 1, and wherever we see a y variable, that's where it's going to go in for. So that means we're going to substitute into the other equation. So we're going to end up with a 3x plus 2 times our y variable is equivalent to a negative 2x plus 1. That's equal to 4. And we go ahead and solve that down for what x is equal to. So a little distributive. So we have a 3x minus 4x plus 2 is equal to 4. 3x minus 4x would leave us with a negative x. I'm going to move that 2 over by subtracting. So negative 2x is equal to 2, which means that x is going to end up equaling negative 2 if you divide by that negative 1. So once I have x is equal to negative 2, that's 1/2 of my answer. I also need to find out what y is. So in the next step, step number 3, it says to solve for the resulting equation containing one variable. So we had already solved down the second equation where we said that y was equal to a negative 2x plus 1. I would go back to that equation. And then if we have that x is equal to negative 2, all you're going to do is in place of x, plug in your negative 2. So that means we're going to have, for step 4 is technically the back substituting. Kind of did these a little bit faster than the steps 1, 2, 3, and 4 that they gave, but it's all good. So we said that x was equal to negative 2. So if we plug in a negative 2 times negative 2 plus 1, that's going to give us that our y value is equal to 4 plus 1 is 5. So we found the ordered pair. We have a negative 2 comma 5, and step number 5 is to check. So just like what we did in the very beginning. 3 times our x value of negative 2 plus 2 times our y value of 5 has to equal 4. That was from that first equation. And then our second equation, we would have 2 times an x value of negative 2 plus 5. That has to equal 1. So if we double check, make sure that it works, we'd end up with that first equation, a negative 6 plus 10 is equal to 4. That works. Second equation, negative 4 plus 5 is equal to 1, and we know that that works. Nice and easy. You should not really be confused on any of that. So solving systems by addition. There is a mistake in your notes packet, and I'm sorry I didn't catch it before I printed it. The section underneath of the solving linear systems by addition gives you the exact repeat of what we just did, which was substitution. So if you want to kind of jot this down somewhere, maybe the back of the packet, I think there's a blank page. If it's something that you need. Otherwise, again, this is Algebra 1 review. Maybe you remember how to do all this anyway. So it talks about solving a linear system by addition. I would also say or subtraction because it depends on how you set up your problems, whether you add or subtract the equations. Back in Algebra 1, we called this elimination. So the steps that go about solving by elimination or solving by, as they call it, addition. It says number 1, if necessary, rewrite both equations in the form ax plus by is equal to c. Number 2 says, if necessary, multiply either equation or both equations by appropriate non-zero numbers so that the sum of the x coefficients or the sum of the y coefficients is 0. It then says to add the equations in step 2. The sum is an equation in one variable. So solve the equation in one variable, and then back substitute the value obtained in step 4 into either of the given equations and to solve for the other variable. And then step 6 is to check the solution in both of the original equations, just like we've been doing. So maybe going through this, you'll remember seeing this from Algebra 1. So solving a system by using the addition method. So they want us to, in step 1, they give us these two equations, 4x plus 5y is equal to 3, and 2x minus 3y is equal to 7. They want us to rewrite both equations in that form, ax plus by equals c, which in this case is already done that way. Standard form, ax plus by equals c. So it has the variable terms appear on the left and the constant appears on the right. So step 2 says, if necessary, multiply either equation or both equations by appropriate numbers so that the sum of the x coefficients or the sum of the y coefficients is equal to 0. So we have a 4x and a 2x. And so the question I'd ask myself is first off, are they the same numbers? No, they are not. I would check my y values. Are they the same numbers? Meaning, are they both 5s or are they both 3s? In this case, they are not. That means we want to decide, is it easier to turn a 2 into a 4 or a 3 into a 5? Well, obviously, turning a 2 into a 4 is going to be a lot easier. What would I have to multiply by to turn a 2 into a 4? Well, we'd have to multiply by 2. So what they want us to do is they want us to take the second equation here and they want us to multiply by 2. But they want us to use addition, which means they want these two terms, when I add them together, to make 0. So if I only multiply that second equation by a positive 2, I'm going to have a 4x and a 4x, which is why I say if you want to subtract, you can subtract. Otherwise, take that second equation and multiply it by a negative 2, and that would give you the correct signs that when you add those two pieces together, you end up with 0. So we're going to take our first equation and rewrite it as is. So our first equation is just going to be that 4x plus a 5y is equal to 3. And now our second equation is going to end up multiplying by this negative 2. So I'm going to have a negative 2 times each of those. That's going to end up giving us a negative 4x. A negative 2 times a minus 3y is a positive 6y. And a negative 2 times 7 is going to give us a negative 14. And now from here, we'd be set up to solve. So in step number 3 below, it says to add the equations. So I'm just going to go ahead and do that here. I'm going to take these two equations, could have put a bar underneath and put a plus sign. So when I take a positive 4x and I add a negative 4x, our goal is to eliminate that variable, make it a 0. There's no longer any x's. I have a 5y that's going to add with 6y, which is going to give us 11y. And then 3 added with that negative 14 is going to give us a negative 11, which means that y is going to equal a negative 1. So once I added those equations together, it says to solve the equation in one variable. So we just figured out that y was equal to negative 1. We already took care of that. Now I would want to, for step 5, back substitute into one of those equations to find out what x is going to be. So pick an equation that looks a little bit easier. I don't think either one of them looks more or easier than any of the other ones. Maybe I'll take the second equation and use that one. So I'd have a 2x minus 3 times a y value we said was going to be a negative 1. That has to equal 7. So we'd have a 2x plus 3 is equal to 7, which means 2x is equal to 4 and x is equal to 2. I think you guys can mentally do those steps without having to show all that. If you needed to see what I did, right, we subtracted 3 and then we divided by 2. Some of these steps you'll be able to do kind of quickly in your head, but I still want to see some of the work that you found. And then for step 5, we have an x value, we have a y value. We did that by back substituting. Step number 6 says to just double check. So if I take that first equation, right, we said that we're going to have an x value of 2 and a y value of negative 1. So first equation, I'd have a 4 times x value of 2 plus 5 times y value of negative 1. That has to equal 3. So 8 with a negative 5, is that equal to 3? Looks good to me. Second equation, we have a 2 times an x value of 2 minus a 3 times a y value of negative 1. That has to equal 7. So 4 minus a negative would be a plus 3. Is that equal to 7? Yes, it is. That means 2, negative 1 is our correct solution for this problem.